Today we're going to talk about converting an oxygen regulator to a dome-loaded operation. Now, why would you want to use a dome-loaded regulator? Chances are you want to use remote control using a pneumatic system in order to simplify your automation. Why would you want to convert a standard regulator to dome-loaded? Basically because you're a cheapskate and the standard regulator is easy to get. Dome-loaded regulator is typically a special order and rather costly. So I'm going to try converting this regulator. It's the first time I've actually done such thing. So this is a Harris Model 25 oxygen regulator that I got off eBay. It's actually a medical regulator, but it's basically the same design as any other single-stage gas regulator. So you'll notice that although this is a manual regulator, it doesn't have a T-handle the way you would normally adjust it. That's because this one was set up as a fixed regulator. There's an acorn nut on top of here that protects the adjustment. The adjustment is a screw, goes in and out. None of that really matters to us because we're going to get rid of the screw and the spring that it works on. So the first thing to do is to back out the control to zero pressure. That takes the pressure off the spring, and that will make it much easier to disassemble the regulator. The regulator consists of this bonnet and a base piece, and they unscrew. This one I've already had open, so it starts really easily. You'll probably want to clamp this in a vise to get it open the first time. So here's what the inside of that regulator looks like. You've got the valve stem itself down in here. It's actuated by a steel plate on the bottom of this rubber diaphragm. Let's get the diaphragm out of here. Well, we'll get that out in a minute. We'll back out the screw all the way, and then we can push on the spring. Poof. Okay, this is just a hollow bonnet, nothing in it. This is the spring. This is the seat that the adjusting screw works against. We don't need these anymore. This is the diaphragm. This is what senses the output pressure and actuates the valve. The spring sits on this side, and the function of the spring is going to be replaced by air pressure. The controlling air pressure goes on this side of the diaphragm. The oxygen gas that's coming out is on the other side of the diaphragm, and when those pressures are balanced, why then there's no force on this. If the oxygen pressure is too low, the air pressure on the outside will push down, and that will push on the valve stem and open the valve and let high pressure gas in. I noticed that on this regulator there's actually quite a stiff spring on the valve stem. You would hurt your finger pushing down on it directly, but there's several pounds of force. And that's the pressure that needs to be developed by the diaphragm, forces on the diaphragm in order to actuate the valve. There's one other item here, which is called a slip ring. This is just a little fish paper washer. It goes on this side, So it's going to wind up sitting in here. The purpose of that is when you screw this on, it makes it easier to turn without damaging the rubber. That's actually a concern because in the standard regulator, the bonnet is open to the air. Not only do the threads around here leak, but there's actually there are holes that are drilled in the metal of the bonnet, so that when you're using it in the normal spring regulator mode, it's free to air. That also means that it's completely unimportant in the normal operation to have any seal between the diaphragm and the bonnet. When we convert this to dome-loaded, we need this to be a sealed chamber that we run our pneumatic pressure into, which means we do need this surface to be a seal, and we need to plug up these holes, and we need to connect some sort of air fitting to inject pressure to it. So my theory is that we actually will have to remove the slip ring so that the rubber of this side of the gasket will seat against the inside of the bonnet, and we'll have good sealed cavity up there. It may wind up being necessary to put some gasket sealant or some I think maybe the first thing I'll try is putting some vacuum grease on here so that it will still assemble nicely and hopefully seal up well. So, the first piece of this project is sealing up all the holes in this. There's lots of ways you could do it. I believe this is chrome-plated brass, so you should be able to solder to it. You could put plugs in those holes. My plan is to use JB Weld, which is just a filled epoxy. You also have to get some sort of air fitting here. I came up with kind of a kludge way to do it. This is a straight thread, probably a 1/2 13 or something like that. And I want to get this to a plumbing fitting, like a pipe thread. Pipe thread won't screw into this hole. Okay, it's wrong pitch. My workaround is I happen to have a tap and die set, so I took a pipe thread coupler and ran the die down it, so it's now 1/2 13, and this will sort of screw in the hole. Well, of course that's not going to make any sort of seal, but we're going to throw some epoxy on it, and then it should work like a charm. So, here we go. A little JB Weld. Great stuff. Mix it 1:1. Okay. I'm going to smear this on the threads. Run it into the hole. Lighten it up. Maybe smear some goop around the remaining threads, just to be sure. And there's our air fitting. Now how about these holes? I am going to take a little screw, goop that up with epoxy, and jam it in the hole from the inside. And I think that also will successfully make this into an airtight You might be able to just epoxy the hole shut, but I feel more secure having a piece of metal, namely that little screw. So I'm making sure that there's epoxy around the edge. I could have used a little more epoxy here, I suppose. In fact, maybe I'll mix up just a tad more. So one good feature about using a dome-loaded regulator is, naturally its main function is that you can remotely control the regulated pressure with a simple pneumatic regulator. And you can hook that up to an automation system. You're just controlling shop air. That's cool. But a byproduct you get for free is that you can use this functionally as an on-off valve, because if you release the pressure on the dome regulator, why, it will shut off. In fact, if you remember how much force this spring has on it, why, it's going to seal really, really solid when there's no pressure on the other side pushing it. So that means that you can have the effect of a gas solenoid valve by running a solenoid valve on the pneumatic side, and the oxygen-rated gas solenoid is kind of a special order and can be costly and hard to maintain and stuff like that. A solenoid valve to control shop air is, you can get it for $15. It's replace it anytime. It gives you the functionality of an electrical solenoid valve in the regulated gas line for much less cost. So it's going to take a little while for this epoxy to harden, so we'll come back to this in a few hours and finish it up.